Hey, how's it going? This is Mr. Hernandez, and I got a couple of requests to go over this one. The work we did in class today with exponential functions, it applies to this, but I want to make sure I um, go over this, directly. So we talked about how exponential functions, you have y equals a times b to the x, where a is your initial value or your y-intercept, and b was the multiplier. So that exists for this too. You see this is basically a little bit different than what it looks like down here, but pretty much the order is the same, where you have this being the first term, or the first value, initial value, which is right here. That's your first term. So this would be -3 would go here. And then the second term here will be your multiplier. So what will you have to multiply -3 by to get to +6? And it should be the same thing you multiply +6 to get to -12. Well, let's take care of one at a time. So 3 times what is 6? Well, it's times 2. But -3, notice this is a -3, times 2 would be -6. But if I made this a -2, then a -3 times a -2 will give you a +6. Well, let's just see if that rule is the same over here. Is +6 times a -2? Will that give you -12? Yes, yes it will. So this will be a -2 as a multiplier. Okay, let's look at another one. So again, this is our first term here. That's your first term, or your initial value, which is right here. That's your first term. So that is going to be 4 in the first spot. And then this here is going to be your multiplier. So 4 times what is 12? Well, that's times 3. Is this the same here? 12 times 3 equals 36? Yes. So that will make this 3. Okay. So let's try that again here. This is your first term, and that is going to go here, which is 8. And your multiplier is going to go here. And so 8 times what is 16? Well, that's times 2. And is this true here? 16 times 2 is 32? Yes. So your multiplier will be the same since it's a geometric sequence. Geometric, remember, is always going to be multiplying by the same number each time. How about here? So the first term is going to be -1. And your multiplier, well, 1 times what is 4? Well, that's 4. 4 times what is 16? That's 4. But notice the signs, they alternate, right? From negative to positive, positive to negative. And the only thing that does that is if it's a negative value. So we're going to multiply -1 times a -4 is a +4. A +4 times a -4 is a -16. So it does work out. So this is going to be a -4. So basically, if the signs ever change, it's a negative. Okay, now this, notice this at a 90. So this is the most advanced example. So again, your first term is going to go here. Your multiplier is going to go, well, this is going to be times 3. The signs don't change, so you're not going to multiply by a negative to switch the signs. So this is just going to be a 3. And then to get extra credit here, this is asking right here. It says a 4 instead of an n. So that's basically saying a step. What step is this? This is the 4th step. So what is the 4th step gonna get? Well, this is the first step, 2nd, 3rd, 4th. And so this would be the answer that would go in this box down here. So in order to get that, we got to multiply by another negative, or just a 3. And so let's see, negative 99 times 3. Let's see, that's 27. Oops. And then 27, 28, 29. And that'll be a negative. So this would be a negative 297. And so that is, the most advanced, example where the number down here, it's a subscript. It's a small number below the a, almost like an exponent, but it's basically just telling you that that's the step that it wants. And so you have to fill in the blank there to find it.